Hey everyone, I'm Amir Makshari and I will be presenting the paper IoT Bugs and Development Challenges, which is accepted to the technical track of XC21. Me and Professor Ali Mesbah from the University of British Columbia are the authors of this paper, and the paper's artifact has been evaluated as reusable by XC committee and is also available on GitHub. To give a short definition, IoT is a network of physical objects that are embedded with sensors or actuators, and they can interact together or with human beings to deliver different goals. And as official statistics suggest, in year 2021, IoT enters a new phase, which is having the number of IoT-specific devices outrunning the number of other devices. And this number is estimated to go beyond 30 billion by 2025, which calls attention to the importance of IoT development. But as we see all the growth in the IoT space, we want to study how IoT developers are dealing with these systems and what obstacles they are facing. So in the right-hand side, we see a typical multi-layer architecture of IoT systems, and IoT development teams have to consistently deal with such multi-layer architectures, different physical devices in multiple layers, and also different standards and protocols used by distributed components. So IoT tends to have unique bug and development characteristics, and in this paper, we studied these factors systematically. So we proposed two research questions, one about the classes of bugs and the other about the challenges IoT developers face in practice. In order to answer these research questions, we did a bug analysis followed by developer interviews and survey. So for the bug analysis section, we mined GitHub repositories, and after applying some filters such as the IoT related topics being used, the number of bug reports, and stars they have, we came up with 91 representative IoT repositories after some manual analysis. And these subject repositories can cover all layers of IoT architecture reasonably well. And and then we started to collect their valid bug reports. And after having a big pool of more than 5,000 IoT bugs, we started to iteratively sample batch of bug reports and doing root cause analysis of them on them. So we did labeling and solving conflicts in labels in each iteration until we reached a state of saturation where no unseen bug category would appear with labeling new bug reports. So we labeled 323 IoT bug reports until getting into saturation. For interviews and survey, we included more IoT repositories and we contacted their contributors for participating in our survey. And also for interviews, we only considered the top 3 contributors. In both interviews and survey, we asked IoT developers about whether they agree with our bug categories and if they know any new bug category that has not appeared in our data. We also asked some open-ended questions to uncover their development challenges. We analyzed all these qualitative data based on a grounded theory approach. And we finally interviewed 9 and surveyed 193 IoT developers until getting into saturation. And the response rate was about 10%. Regarding interview participants, they have different roles in software and hardware lead and development sections of IoT solutions, and also in different domains. Most of their IoT projects are in different layers of architecture of IoT architectures, and some of these IoT projects have millions of monthly active users. The level of expertise of interview participants also vary from 3 years to 20 years of IoT development. Our survey participants also work on different layers of IoT projects from more varied domains. Both developers and researchers have participated in our survey, with more than 66% of them having at least 3 years of experience in IoT. Now we will talk about our findings regarding RQ1, which is about categories of IoT bugs. So we propose a multifaceted bug taxonomy for IoT systems by considering the locations and components that each bug relates to. This taxonomy is initially constructed with our bug analysis and is further enhanced by inputs from IoT developers during interviews. Finally, it was validated with a larger number of IoT developers via an online survey. As we can see, there are 5 major categories of IoT bugs in this taxonomy, and in the next few slides, we will go quickly describe each of them. So the first major bug category is about IoT devices and can be subcategorized into hardware and firmware issues. Some example of hardware issues are battery issues and wiring issues, and they're more about related to the physical aspects of the devices. However, the device firmware issues are more about bugs occurring within the programmable components embedded in IoT devices, such as the device operating system or bugs in the hardware abstraction layer. The other major bug category is communication issues. So connectivity is one type of such bugs that can be associated with the network issues or devices' inability to handle connections. Issues with the telemetry, messages being sent or received by IoT devices is the other subcategory of communication issues. Another parent another parent bug category is problems with cloud or edge services, and automations are one such services where logical rules are applied among different IoT devices, and failures in delivering these rules fall within this subcategory. Then we have device management issues that characterizes the bugs related to syncing IoT devices with cloud or edge. Problems in registering IoT devices to the cloud and edge, and also issues with reading and writing device states remotely in real time fall within this subcategory. The other two major bug categories are more generic. So one of them is about the compatibility of components together or with IoT systems, and the other is about general development issues such as authentication bugs or user interface issues. So during our root cause analysis, we traced different levels of causes that contribute to each IoT failure until we found the actual root cause for the failure. So this 2D table shows 9 different root causes of IoT bugs. So most common root causes are general programming mistakes in hardware or software code, but some of them are more sophisticated, such as concurrency and memory related issues. Regarding the survey results, all bug categories have been faced by at least 82% of IoT developers. Communication issues are the most frequent IoT bugs, and both device-related issues are among the severe bug categories. Regarding RQ2, we characterize IoT development challenges, and in the following slides, we describe some of these challenges. So one significant theme of challenges in our data was testing and debugging challenges. 74% of IoT developers confirm that they struggle to debug without proper access to IoT devices. As one of them mentioned, that they have to constantly reverse engineer the behavior of the actual hardware device in order to debug their IoT system. Also, fault localization was something that was mentioned by 17 different IoT developers and is agreed by more than half of the survey participants. And one hardware lead developer mentioned that they needed to add extra LEDs just to debug device level bugs, which was really hard and challenging for them. Some IoT developers mentioned their struggles to reproduce IoT bugs. As we saw some examples, IoT developers using ice packs from their freezer just to reproduce a specific bug about the temperature sensor. And also, our results suggest that IoT testing relies heavily on developers instead of separate QA teams. And regarding test automation, only 5% of IoT developers used fully automated testing approaches. Regarding other types of challenges, 61% of IoT developers believe that it's overwhelming to keep pace with all the frequent breaking changes from too many third parties in IoT space. Moreover, 18 IoT developers pointed out the challenge of installing new updates on already deployed IoT devices, specifically in large scales. There have been more challenges discussed in the paper, such as combinatorial explosion, handling IoT failures, and also IoT security challenges. So to wrap up, first we characterized IoT bugs by proposing a bug taxonomy and classifying bugs root causes, which can help IoT developers to an overview of common pitfalls, and also it shows an open space for more detailed and sophisticated research for each bug category. Our finding regarding the IoT development challenges also point out some interesting research problems that require more attention from the software engineering community. In this link, you can find the replication package of our study. Thanks everybody for listening, and I can take questions now.
Earlier. So if I see that everything is nothing at all,
so I think we're live. Yeah. Okay.
This should be under 10 seconds. Huh?
I think we're live now. It shows me that we are live.
Okay. We are here with Amir, the author of our last paper for this session, IoT Bugs and Development Challenges. Amir is last year master students at UBC, and this is his first paper at TIXI. So I'd like to first of all congratulate with him on his first paper at the top tier conferences. And also, I want to highlight that this paper has an artifact reusable badge, which is also a very good practice. So you really started with the right foot, Amir. Let's start with the question. So James says, great study. Can you talk about comparisons between your study and bug challenge studies in other domains? So what makes IoT special, I guess, right? That's probably the summary of the question of James.
So I think like one special feature in IoT is, first of all, there are multiple layers. So there's not like a single system. There's not like a single domain that you have to focus on. You have to go and gather all different projects in different layers of IoT. So when you're mining repositories and when you're focusing on IoT, you have to include device related and hardware repositories that are used in IoT, edge layer repositories and cloud layer repositories. So the thing that is very important is to consider all of these layers and not be biased towards only one layer, because there are certain insights that come from like a certain layer in IoT. And if you miss that layer in your repositories, in your subject projects, you are going to miss some insights related to IoT. So that's like I would say that's a very bold feature in IoT in empirical studies.
Okay, thanks.
And like one other thing that I wanted to add is that also when you're doing this survey and we're doing the interviews, people like developers are coming from different backgrounds. So like a hardware developer, a cloud developer, and like even an edge developer, they have different background, they have different viewpoints, and also different skill sets. So it's a little bit hard to like challenge and like understand the challenges of each of them specifically and like tag them as we go. Yeah.
Understood. There's a follow-up question by James. Are IoT developers different from developers in other domains? For example, more folks has EA backgrounds and less training in software. So based on your interviews, you already said that the developers have different background, the one you interview, but have you found that IoT developers have different background from developers that work in other domains?
Yeah, thanks, James, for like, this is a really interesting question. So this is actually, so IoT developers are different, but there's not a notion of IoT developer. So there are different kind of developers that contribute to IoT systems. And you cannot find a person that says like, I'm like, there are some people that do IoT, like full stack IoT development, but there are different people in different parts and they may contribute to a full IoT system. So basically, they come from different backgrounds, and that is very right. The thing that you mentioned about less training in software, that also happens when you're dealing with hardware developers. They usually, sometimes they don't have ideas about like the other programming languages and what's happening in like the cloud layer and those parts. So they're usually focused more on the embedded part and the hardware part. But yeah, that was a really interesting thing to point.
Okay, Yeah, thanks for the answer. It's pretty interesting as well. And I have a curiosity myself. Can you tell us a little bit more about your experience in running this survey? Like from based on my experience, it's pretty challenging to engage with practitioners. So I see you have carried out 9 interviews before building the survey, and then you had to reach out participants to fill the survey. Just was wondering how's been your experience with that, and how long it took to run the
Yeah.
study, and if you have any tips to share with us on how to engage with the participants, basically.
Yeah, that's a really valid question because it was actually a challenge for us as well. There was an IoT specific challenge that I mentioned earlier that there are like the repositories and the developers are in distributed in different backgrounds and different like domains. So you basically have to mine different domains and find different projects. So this is one IoT specific aspect, but like in general aspect, first of all, it's really good to use the right tools. And if you don't want to use a good tool that help you, it's going to be very challenging. So I started with not using a tool, and then I moved to using a tool, and everything was really convenient after that. So the tool that we used was Qualtrics, that we also mentioned in the paper. And also for when you are contacting the developers, it's really good to give them the option of unsubscribing. And it's gonna be really helpful because that way you are valid to send reminders to developers. And reminders usually do better on people usually contribute more to reminder emails than the first email. So they usually it happens a lot that developers ignore the first when you reach out to them, ignore the first time, and then the second time when you send a reminder, they see that it's a valid thing. But there's an ethical part that you have to give them the option of unsubscribing. Yeah.
Sure.
And
That's
also and also the same thing that I mentioned about tools also apply to the interviews as well. So when you're doing the interviews, if you're doing it like without using any tool, it's gonna be really hard to like write all the transcripts. But we use a tool that kind of generate automatic transcripts that help a lot. And it took us around like 6 months to like do all those parts.
okay. That's pretty useful. Thanks for sharing your experience. How many participants you got in the end for the survey?
Yeah,
How
for the
many
survey, but
respondents?
for the survey, there were more than 400 respondents, but not
Okay.
all of them completed the survey. So basically, 193 people completed that, and when we didn't include the people who were like going through the first page and then didn't continue.
Sure.
So that's. But yeah, it's really important to keep the survey also short.
Sure.
Um, yeah,
We
and
face
for
the
the
same
interview.
challenge with our one because there's abandonment, so people start doing it and then leave, and it's very good tip to take in mind that these people may get bored, so the shorter the survey the better, but at the same time you want to grab as much information as possible, so it's really important to design the survey uh, properly beforehand. You were
Exactly.
adding
Yeah.
something and interrupted you. Please go ahead if you. I think you were saying something more.
Like basically, I just wanted to, because like we have 40 seconds left, I just wanted to wrap the
Yeah.
thing that we learned. So basically, I think maybe I can talk a little bit about the future works. So basically, the taxonomy we provided is we try to include like all aspects. And if you look at the taxonomy, we can see a high-level picture of bug categories in IoT. But there, we could, as we were tagging the bug report, we could see a strong potential to focus on each bug category specifically and doing empirical investigations on each of them. So I think that can be like one of the strongest like future works for our study.
Yeah, absolutely.